In today's class, we will see about arrays in C. So let me start today's lecture. I have started the recording. Those who will join late can see the recording of the minutes they have lost. All right, so let's start. So what is actually array? Array is a data structure which consists of related data types of same type, right? So it is a collection of objects which are of same type. If you remember a data type list that we have seen in Python, so list is again a collection of objects, but in that case the objects could be of different type, right? It could be a string, it could be a character or integer or floating value or anything, or it may be a list in itself, right? But that is not the case in arrays, which is there in C. So arrays is a data structure which consists of related data items of same type. Okay, so this particular thing is important. Everything should be of same type. If it is an array of int, all the values stored in that data structure should be of type int. All right. There is another notion of struct that we will cover a little later in this course. So struct is a collection, again it is a collection of data items, but there C is giving us the flexibility to keep possibly different types of objects, right? But in array it consists of same type of data items. Okay, and arrays and structures that we will cover later, both are static entities in the sense that once the program starts its execution, the size cannot be changed. It is static in nature. So if you define an array of size 10, through the entire execution of the program, the size remains 10. Okay, so this is also how it is different from the list that we have covered in Python. In list, dynamically it is increased or decreased, the size I am talking about, right? But arrays, so first thing is arrays is a collection of same type of data items. Second, it is a static data structure. It means the value or the size of that data structure will remain same throughout the execution of the program. Okay, the values definitely you can change during execution. Now, how these arrays are stored in the memory? So C allocates a continuous memory location to these arrays. Okay, so if you remember, we have seen the concept of random access memory, RAM. So in RAM, this data structure will get continuous allocation. Okay, so if I will say that, okay, let's make an array of size 12. So this is the array of size 12, 0 till 11. Okay, the index goes from 0 till 11. And this is the position. This is how they are stored in the memory. Continuous memory location is allocated to array, right? And therefore, if you say is index 0, it will return minus 45. If you access element at index 8, it will return minus 3. So C is the name of the array. Inside bracket, okay, this is the index of the array. These are also called subscript. Okay, and this 45 minus 45 is the value of the array at this particular location. Making sense? So the indexing start from 0th element. Okay, so array, like other variable names, can contain only letter, digits and underscore, but cannot begin with digits. So the rule of nomenclature of an array is same as it is in the for the other variables in C. So any variable name, you can include letters, digits and underscores. You cannot include any special characters. And one more restriction is you cannot start the name with the digit. In between, you can use the digit, right? So same rules applies to array as well. So array also, you can use letter, digits and underscore in the name in defining the array, but you cannot start the name of the array with a digit, right? And the position number or the index number which is written in the square bracket is called subscript. Okay, and this subscript must be integer. For obvious reasons, right? You can understand why it is integer. It cannot be any floating point or any value. But yes, it could be an integer expression as well. Okay, so for example, let's see that if a equal to 5 and b equal to 6, right? So you can write c of a plus b. So first of all, this a plus b will get evaluated. Okay, a plus will b will give you 11. So we are saying c11. Okay, c subscript 11 is plus equal to 2. It means you have to add 2 to this particular element, c11 element. Okay, 11th element of the, or c 11th location of the array. Is it making sense? Yes or no?
Yes,
Yes,
ma'am.
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. A subscripted
Yes,
array
ma'am.
is the L value, means, assignment you have to do at the left side, right? You cannot assign anything by writing it on the right hand side, right? So same rules apply for array also as variable, right? Okay. Now let's work more with arrays. So what is C? C is the name of array. What is the size of the array? So it contains 12 elements. Okay, it contains 12 elements. How we will refer to those elements? We can refer to those elements using position number starting from 0. So if there are 12 elements, the position number start from 0 till 11. Okay, and the value which is stored at any location will give you the actual value that is stored in this particular variable. So C0 is equals to minus 45, so on so forth, right? Now if you want to print, right, if you want to print any value, same as we are doing it for any variable, we will do similar things. We will use %d because this is an integer type array. If this is a character type array, you can use C. If this is unsigned int type array, you can use U, so on so forth, right? And then you can do any operation on this. So it act like a separate variable. Okay, so you can say that these are actually 12 variables, different variables, but with certain restrictions. So continuous memory is allocated to all these variables and they should be of same type. Okay, so to divide the value of element, okay, so this is how it will done. Now there is one more thing. So suppose if you want to divide the value of element 7 of the array, okay, by 2 and assign the result in variable x, how we can do this? Okay, now you have to speak up. How we can do this? Just read the last line and tell me the syntax. We have to divide the value of element 7 of array C by 2 and assign the
X,
result in
X
variable
by our
C
X divide
X
by
equal to
X equals to
C8
C7
divided by C3.
C6.
C6 divided by
Yes.
2.
very correct. X
Sorry,
equal
C3 divided by C1.
to, right, X
C6
equal to C6. This is also important, right? C6,
yes,
because we have to divide element number 7. Element number 7 is stored at C6th location. Okay. So we can write X equal to C6 divided by 2. Okay. So this is how we can use arrays. Okay. Now this bracket is having the same precedence as the other parenthesis. So first it will get evaluated and then rest of the operations will occur. All right, now let's see how we can define the array. So if you want to define an array, you have to write the data type, the data type of the elements to which the array belongs to, or the data type of the elements which will get stored in that particular array. So suppose we want to make an array of 12 elements with integer data type. So we have to write int C, and then in the bracket you have to define the size of the array. After that you have to put a semicolon, right? So this will actually define the entire array. Am I making sense here? You have to put a semicolon also. So this is actually a C statement. Okay, so in one line we can define two variables, right? Here also we can define two arrays. So int b100 comma x27. So what it will do, once this particular statement or instruction will get executed, it will actually reserve 100 elements for integer type, and the name of that is array B, and 27 elements for integer array X. Okay, so these two arrays get allocated in a continuous memory location. So these 100 location are continuous and this 27 location are continuous. Okay, but it is not required that these two also continuous. Okay, and index goes from 0 to 99 in this case and 0 to 26 in this particular case. If you want to define an array of characters, instead of int, you can write char, C-H-A-R. Okay. All right. Now let's have, so we will talk about strings. Strings are also very much related with array, but we will talk about strings after we will cover functions. Okay. So after array, we will take functions and then we will come to the string part. All right. Okay, now let's have a look at how we can use an array inside a loop. Okay, and meanwhile we will also see how we can initialize the array element. Now one more thing, one more correlation I would like to mention here about array and variable is this. If we will not initialize any variable in C, what is the value stored there? Garbage value. Same happens with array also. If you will not initialize the array, right? So this is just a definition, right? B100. So it will just allocate the memory space. We are not doing any initialization here. If you will not initialize the array and you will start using any index, it will give you a garbage value. So it is mandatory to initialize the array as well. Okay, we will see how we will initialize it. But first of all, initialization is very much required. Otherwise, it will give you a garbage value. Okay, so let's see how we can initialize it. Okay, so this is a program. What this program is doing, let's have a look. So here we are defining n is an array of 10 integer. Okay, it can store 10 integers. This size underscore t, we will have a look at this data type actually a little bit later, but just assume that this is just an integer type variable I. We will make a for loop to initialize the elements of the array. We will run the loop from 0 to 10. Why? Because there are 10 elements, right? So we have to run this loop from 0 to 10, and each time what we are doing is, each time we are assigning 0 to that particular index number. So when I is 0, n of 0 will become 0. When I becomes 1, n of 1 will become 0, so on and so forth. Okay, so what we are doing in this for loop, we are actually initializing all the elements of the array with 0. We are actually assigning 0 to all the elements of the array. Is this for loop making sense?
Yes, ma'am.
Okay.
Yes, ma'am.
All right.
Yes, ma'am.
Okay, so after that, this is just the string formatting task. We will say, okay, just print element as a header and then print value. Okay, just reserve 13 spaces. So basically S is used for strings. Okay, we will cover strings in more detail, but for now, if you want to, print any string, you can use %s. Okay, so this for loop, line number 11 to line number 14, in these lines, we are initializing the array. In line number 18 to line number 21, we are printing the value of the array. Okay, so what we are printing, again, we will run the loop from 0 to 10, or 0 to 9 actually, and then we will print the value of I and the value stored at the array index I. Okay, n array of ith index. So this is the output. Since we have initialized all the values with 0, okay, it is printing 0. Is this program clear? These contain actually 3 parts. First is how we can define an array of size, some size, say 10. how we can initialize that array, and how we can print the value which is stored. Can use int, anything, no issues. Okay. Now what is size t? Let me show you. So size t actually, it is a standard representation of unsigned integral type. So size t, size underscore t is actually unsigned integer. Okay, it is actually unsigned integer. But you know, there is a C library, C standard library called stddev.h, where this is defined actually. Okay, so you know, generally when you want to keep the size of the array, you can use size underscore t data type. But you know, if you run this program, it will give you the error. You have to include stdef.h. That library you have to include. This particular library, sorry, this particular library you have to include. Okay, and if you don't want to include this library, if you don't want to write like size underscore t, you can just write unsigned int or anything. Okay, am I making sense? Is it clear?
Yes, ma'am.
Okay. So, all right. Now let's see what are the other ways to initialize an array. So this is another way to initialize an array. In the first method, we have initialized the array with a for loop. Okay. Now let's see how we can initialize the array, without using a for loop. So this is the way in which you can actually, write the numbers and it will get initialized, right? So the first position, the 0th index will get initialized with 32. Second index will get initialized with 27, so on and so forth. Okay, so this is how you can initialize the array. This is another method to initialize an array. You have to open the curly bracket, you have to close the curly bracket, and then you have to write all the items comma separated. If you run this program, this is the output you will get. Okay. Any questions here?
No, no.
Okay.
Ma'am, 13D, for what it used?
Again, this is string formatting. You can please refer to the video that I made for, or the lecture that I have taken for string formatting. Okay, I again and again recommend. Yes.
In the output, what will it do?
That is what I am telling you, that please refer to that video. Okay, I have already explained what 13D will do. Okay, please, I highly recommend that please refer to those videos. All right. Now, let's see, another way of initializing. Now, there are few points I would like to mention here is, so suppose the size of n is 10, okay, and you will give lesser number of elements, okay. If you give lesser number of elements, what will happen? It will start initializing the array with 0th index. Okay, it will keep initializing, and suppose we have number only till 14. Okay, so let me just remove, suppose we don't have these numbers. Okay, so this is what we wrote to initialize this array. Then what will happen? Rest of the elements will automatically be assigned as 0. If the number of element in this are lesser, then it will start from for assigning, the value from 0th index, keep on assigning the values. Once it will not get any other value, then it will assign 0 to rest of the indexes. Okay, if you will give more element than expected, it will give you the error. Okay, so if there are lesser numbers, it is fine, no issues. If they are equal number, perfectly fine. If it is having more number, it will give you the error. Okay, so suppose if you want to initialize all the elements, of the array by 0, you can do like this. You can do like this. This particular line will actually assign 0 to all the elements. Why? Because it will just start initializing it with 0. So the first element n0 we have initialized with 0, and now there are no elements, right? So rest of the elements will also assigned with 0. Okay, so this actually explicitly initializes the first element to 0 and initializes the remaining 9 elements also to 0, because there are fewer initializers than the number of elements in the array. Okay, so what that particular for loop is doing, same task could be done by this single line. In the first for
What will happen if we make the bracket empty?
if you make the bracket empty, then you will get the error. Okay, you have to initialize at least one element, at least one element. Okay,
Yes, ma'am.
all right.
Ma'am, what if
Yeah.
we initialize with two variables, 0 and 1, then
Ha.
it will alternate take values?
No, no. So the rule is only one. If there are fewer initializers than element in the array, the remaining element are initialized to 0. This is the rule.
Okay, ma'am.
Okay. All right. So actually we have seen 3 ways of initialization. One, using a loop. Second, using curly bracket with equal initializers as number of element. And the third way could be keeping lesser or fewer initializers than the number of elements. All right. Okay. So it is important to remember that array are not automatically initialized to 0. Please. So here, most of the students will make the error. You will assume that, if we are not writing anything, so automatically it will get initialized with 0, but this is not true. Okay. You have to initialize at least one element with 0, and remaining will automatically initialize with 0. Okay. So any question in this? Say that, madam, in my system it is happening, but here it is not happening. Okay.
Okay.
Yeah.
Ma'am, if
Yes.
we want some another number other than 0 in all
Yes, ma'am.
on all the spaces, then we have to assign each and every to that, or
Then
we
you
have
have
to.
to use. Then you have to use. Loops.
Okay.
Okay. If you write fewer initializer, then rest of the elements will assign 0. You cannot say that all the elements will get 1 or something like that. You have to use other methods of initializing the things.
Okay, ma'am.
Ma'am,
Hmm.
ma'am, previously you have said that if we do not initialize or assign the value of variable, it takes the garbage value. Now it is taking other values as 0.
Hmm.
Ma'am, it
Yes.
should be garbage value only or 0.
No. Why it will be a garbage value? You are initializing one element, right?
Yes, ma'am.
Yeah. What is the rule? What is the rule? If there are fewer initializers, then the element in the array, the remaining element are initialized to 0. Okay, but you need to initialize at least one element, then only rest of the elements will get 0. Otherwise, if you don't initialize any element, then all the element will have garbage value.
Okay, ma'am.
Is it clear now? Any other question related to this garbage value, 0, and all these things? So you just have to keep 2 rules in your mind. The first rule is, if you will not initialize the array, it will take a garbage value. Okay, maybe some of the student will run the program and they will say, madam, I have not initialized the array, but it is still giving me 0. But that is because of certain case. Okay, but what is the general rule? You have to keep that in mind. Okay, we have to make a generalized program, not a compiler dependent program. Your program should be run and behave exactly same on any type of compiler. Okay, this is how we will make a program. Am I making sense here?
Yes.
Yes, ma'am.
Second rule is if you initialize at least one element using this, rest
Yes,
of
ma'am.
the element will automatically get 0. Then you don't have to worry about that. Third rule is if you want to assign different values to each element, then either you can write it or hard code it using these brackets as we did in this case. Either do it like this, or what you can do, you can use a for loop. Okay, so we will see that also, right? How we can assign different values using a for loop. Okay, so just remember, this is a common programming error, forgetting to initialize the element of an array. Okay, you have to initialize the elements of the array. So this is having lesser number of elements, rest of the element will get 0. Okay, if there are more initializers than the size of array, then there will be a syntax error. Okay, now there is one more, a variation in this. Suppose you will not give the size here. You will not mention the size of the array here. Okay, then what it will do? It will automatically create array of size equal to number of initializers. Okay, so there are 5 initializers. It will actually make an array of size 5. Okay, so if the size of the array is omitted in this particular definition, then it will take the size from the initializer list. And what will be the size? Number of initializer will become the size of that array. Okay. All right. Now, one more important thing, which I got one question related to how we can, set the size, using some variable. So you can use a symbolic constants to initialize the array. Okay, now this is a different concept. Please, pay attention here. This is altogether a new concept, and we have not covered it in Python or in any other, lectures. What is symbolic constant? So see, in C, there is this particular thing, hash define. This size is actually a symbolic constant. Okay, these are also called macros, macro, macros. Okay, now what we can do is, instead of initializing or hard coding the size here, we can use symbolic constant, but the value of this symbolic constant you have to initialize in the beginning of the program with the pre-processing directives. Okay, so you have to write hash define size space 10. What this will do, actually, what this will do, it will create a symbolic symbolic, you can say, constant. The value of this symbolic constant is 10, and now you can use in your program this symbolic constant wherever needed. Okay, so what I am doing is I am writing int s size. So what will happen, let's see. Okay, so this is the program now. The first program that we have seen, it is converted in this manner. Instead of 10, we will write size here, and in the beginning we define hash define size 10. Please make a note that we are not putting any semicolon here. Okay. Okay, now see what happened. Here also we are using size. Okay, and instead of assigning 0, we are assigning 2 into j2. We are assigning some expression. Okay, each time. And here also in printing we are using size. Okay, now see what happened. So this is the output. So now what is hash define? This is the preprocessor directive. We all know hash define. Now what it will do is, once the program will go to compiler, before that it will go to preprocessor. Right, we already know that include stdio.h will get preprocessed. At the same time, this size variable will, or I should not say it as variable, this is a symbolic constant. This symbolic constant will also get preprocessed, and whenever in the program there is the occurrence of this size constant, it will get replaced by the value, which is 10. Are you following me here? So in pre-processing, what will happen? It will become S10. This will also become 10. This will also become 10. Okay, this is not a variable. You cannot change the value of size in, in the program. This is not a variable. Therefore, I am telling you again and again, this is a symbolic constant. This is equivalent to a constant that we are using. Just it is a symbolic constant. Can you tell me why we have to use this symbolic constant? What is the advantage of using the symbolic constant?
Ma'am, its value
Okay,
remains
so its
same.
value remains same in the whole program. But what is the use? We can write 10 also, right? At each place, we can write 10.
मैम अगर हमें वैल्यू चेंज करनी है तो हम मैम ऊपर डायरेक्ट वहां से चेंज कर सकते हैं मतलब कितने
Exactly. Yes, very true. So one, very important advantage is, suppose now the requirement has been changed and you want to make the array of size 20. You have to make changes at many places if the program is very huge. Okay, so generally what people do, people use symbolic constant. So if I want to change the value, I will just have to change this value at one place and it will automatically get reflected in the entire program. Okay, and that is why we will use this symbolic constants. And the programming practice, so I already told you that the variable name should start from small letters. Okay, so generally we will keep our variable name with small letter, and the best practices says that if you are using symbolic constant, just use caps, write it into capital. All the letters you can write it into capital, just to highlight, I mean, you will remember that, okay, these are the symbolic constants. I cannot treat it as a variable. Okay, so this is a good programming practice. So this is the use of symbolic constants. Okay, so the symbolic constant is an identifier that is replaced with the replacement text by C preprocessor before the program is compiled. So for compiler, there is no change, okay? But in preprocessor, we are using this extra feature. And this is called symbolic constant.
Ma'am,
Yes.
ma'am, the same thing could have been achieved by using a simple variable as well. So what is the advantage of a symbolic constant over a variable? Could you please tell?
So see, symbolic constant. So if you define a variable, okay, so maybe you are talking about a global variable, right?
Yes, ma'am.
Okay, so see, we will have a look at that later on, because right now we have not covered global variable. We have not covered global variable. Okay, so there are
Maybe not, if not global variable, then we can use local variable only.
right. So
Yes,
you can use the variable. It's okay. You can use the variable. The important thing is, so whenever the changes are required in the program, right now you are seeing a program just for a one page, but in real life you will not get one page program. Okay, so if you talk about the operating system which is written, are you aware of how many pages are there in the operating system code? There are thousands pages of this one program operating system. So are you aware of the complexity of remembering, each and everything, making sense? Yes,
Yes,
or
ma'am.
Yes,
okay.
ma'am.
Yes, ma'am.
So what the symbolic constant will do is this, right now we are looking at very small program. Even in the entire course, we will have a look at very small programs. But, if you see the advanced, use of this C programming, people will usually make or define all this constant variable into one file. So if you want to make some changes, you just have to open one file. Are you getting my point? And all the variables are written there. If we make local variable, then local variable, in each and every file, you have to go and make the changes. if you keep all these things into one file and you just have to include that file in each and every program, okay, and then if you change that particular file, if you want to change any variable name, just open one file, change it, and you are done. Recompile the entire program, you are done. I'm just giving you a hint, okay? I hope you understand what I mean.
Okay, ma'am. Got it. Thank you.
Got it? Okay. All right, so this is the use of symbolic constant. So symbolic constant specify array size, makes program more scalable, in the sense if requirement change, just by changing, making change at one location, the code will change entirely. Okay. Okay, so one common programming error, do not include semicolon at the end of define or include, because these are pre-processor directives. These are not C statements, okay? So if you have noticed, we will never put semicolons here. Whenever we use pre-processor directives, don't use semicolons in the end.